This is a video report for Lab 5. So for the introduction, basically the things that we're using here are Faraday's law, flux, and magnetic force and superposition. We're also going to rely on some things from earlier labs and from earlier classes, such as the force of gravity and the dipole moment of the bar magnet that we calculated in Lab 3. So for the assumptions and sources of error, the observed times for entering and exiting the tube are based on putting the clip in iMovie and scrubbing it, which is accurate to the 10th of a second, and the simulation is accurate to the 1,000th of a second, so those aren't exactly the same order of magnitude, so that leaves a little bit of room for error there. The north end of the magnet was found by looking for a positive X component in the magnetometer app, and whichever one read with the positive X component would be the north end. And due to fluctuating readings, there's likely some error with that process, but it's not likely that that affected the overall outcome of that part. And the magnitude of the bar magnet's dipole moment from Lab 3 resulted in a really weird graph, so I just reduced it slightly in the simulation until I got a graph that looked like it should have. And I've also ignored external conditions such as the phone moving and whatnot that could have possibly impacted the results in the experiment. So basically the experiment, you need a magnetometer app on a smartphone that measures the X, Y, and Z components. You're also going to gather the necessary materials and then identify the north pole of the bar magnet. You'll record a video dropping the bar magnet through the roll and identify the exact time the magnet entered and left the roll. And then we're computing desired calculations through a GlowScript program and comparing some results after that. So here's a picture of the procedure. Basically, you're dropping the magnet with the north end down through the roll, and you're going to calculate the time that it was in the magnet, or the time that it was in the roll. So now for the data. The key observations here, the magnitude of the dipole moment of the bar magnet that I use in my simulation is 1.076. The roll of aluminum foil is 0.36 meters long and 0.016 meters wide with an inner radius of 0.015 meters. And the bar magnet entered the roll at 3.8 seconds and exited at 5.2 seconds, which means that it took the bar magnet 1.4 seconds approximately to travel through the roll of aluminum foil. And here is a video of it.